Welcome for our video today, and today we are going to look at our very important theme. In this lesson, we are going to study or practice how to balance chemical equations. This is very important. When you know how to balance chemical equation, this will be, when you shall be looking at a mole concept, this will be very helpful. Because in calculations involving the mole concepts, balancing of chemical equation is the key for you to be able to know the mole ratios for the reactants and the products and so on. Now, our first equation that we got here is an equation between aluminium metal, oxygen gas to give you aluminium 3 oxide. Now, what you do for you to be able to balance an equation is for you to be able to analyze the molecules, analyze the elements. For instance, now the first reactant here, which is aluminium, is a metal which is appearing as a, not even, is a metal, is an atom. So it's a single atom for aluminium like that. Now our next reactant is oxygen gas. As you can see, we have it's 0 O2. O2 means that we have 2 atoms of oxygen like that. Now we have 1, 2. This means that this is the molecule for oxygen. Now this compound here now that has been formed has got 2 atoms of aluminium and 3 atoms of oxygen. So this one is called aluminium 3 oxide. We can represent it like this. Now this is interpretation of this molecule. 1, 2, 3 oxygen atoms and 1, 2 aluminium atoms. Now this side, we call it the side of the reactants, and this side is the side of the products. For you to be able to balance this equation, what usually comes into one's mind is the number of atoms in this side, on this side, should balance the number of atoms on this side. Now, the number of atoms of aluminium on this side should balance the number of atoms on this side. The number of oxygen atoms, like now we have 2 on this side, should balance the number of atoms on this side. So let us start with aluminium and see whether these atoms are balanced. Now, we have 1 aluminium atom on this side and 1, 2 on this side. So what we do is that we add an atom. We try to balance by adding 1 atom of aluminium on this side. So such that now we have 2, and on this side now we have 2. So aluminium atoms so far are balanced. Let us now look at oxygen atoms. On this side we have 1, 2. And on this side we have 1, 2, 3. So that means we have a deficit of 1 here. But you should remember that now we cannot add a single. Oxygen is a gas, and we always react or get involved in a chemical reaction as a molecule. So we are going to add a whole molecule of oxygen as we try to balance the number of oxygen atoms on both sides. Now we see, if you add a whole molecule, we result in having 1, 2, 3, 4 atoms of oxygen on this side, whereas we have 3 on this side. Now we have to do something on this side to increase the number of oxygen atoms. And the only way we can do that is by adding a whole molecule of aluminium 3 oxide, like that. So at the end of the day, you have 1, 2, 3, 4, 5, 6 oxygen atoms. Where on this side we have 4. So to make them 6, we add another molecule of oxygen. That is 2 atoms of oxygen. So now they are 6. 1, 2, 3. 1, 2, 3, 4, 5, 6. Just as in this side. 1, 2, 3, 4, 5, 6. But you realize now, once we are trying to balance the number of atoms of oxygen, we interfered now with the number of aluminium atoms. So we have 1, 2, 3, 4. On this side we have 1, 2. So what we do, we add 2. Remember, aluminium is a metal, so it can react as an atom, and like for all gases, they have to react as molecules. So now we have 1, 2, 3, 4 of aluminium, 1, 2, 3, 4 of aluminium. Then we have 1, 2, 3, 4, 5, 6 of oxygen, 1, 2, 3, 4, 5, 6 of oxygen. So the number of atoms for aluminium and oxygen on this side of the reactant have balanced with the number of atoms of oxygen and aluminium on this side of the products. Now, we need to see how now we need to add now our coefficients. So we have 1, 2, 3, 4 aluminium atoms, so we add a 4 there. We have 1, 2, 3 oxygen molecules, so we are going to put a 3 here. This is what we call a coefficient. And then we have 1, 2 molecules of aluminium dioxide, so we are going to put a 2 here. So our equation is balanced. Now there are 4, 4. And this one, there are 3, 1, 2, 3. If you multiply 3 by 2, you get a 6, 1, 2, 3, 4, 5, 6. So that means that we have 6 individual atoms, but 3 molecules. Now when you come to this side, you have 2 of this. Now if you multiply 2 by 2 for aluminium, you get 4, 1, 2, 3, 4. And if you multiply 2 by 3 for oxygen, you get 6. And our equation is balanced. Now let us look at another equation for a reaction now between hydrogen sulfide, that is a gas, with oxygen gas, like this, to produce sulfur and water. Now we have to have another addition, sulfur and water. So that is our product. Now, for us to be able to balance this equation, we have to understand that we have hydrogen atoms here, we have sulfur atoms here, and we have oxygen atoms on this side. The same on this side, we have sulfur, hydrogen, and oxygen. So these atoms must balance on this side of the reactants with the atoms, the same atoms on the side of the products. So let us first of all analyze these molecules here. So the first molecule is hydrogen sulfide. We have H2, and we have 2 hydrogen atoms and 1 sulfur. So that is our analysis: 2 hydrogen atoms and 1 sulfur. Then we have an oxygen here molecule. That means that an oxygen molecule is made up of 2 oxygen atoms. We have a sulfur atom. Remember, sulfur can react as an atom. Then we have water. Water, we have 2 hydrogen atoms and 1 oxygen. So this is the analysis for these molecules here. Now let us start with hydrogen. Let us start with balancing the hydrogens so that number of hydrogen on the reactants equals the number of hydrogen on the product. So we have 1, 2, but on this side we have 2. So up to that level, the number of hydrogen are balanced. Let us now look at the sulfur. Sulfur, we have 1 on this side and 1 on this side. So sulfur so far are balanced. Now let us look at oxygen. On this side we have 1, 2 atoms of oxygen, while on this side we have only 1. So what we do is that now we are going to try to make them 2. And by trying to make them 2, the only thing we can do is by adding a whole molecule of water. So see, now we make them 1, 2. Now you realize by doing that, we have also added extra 2 atoms of hydrogen. So we need to add 2 atoms of hydrogen on this side. The only way we can do that is by adding a whole molecule of hydrogen sulfide. That's that now we have 1, 2, 3, 4, and 1, 2, 3, 4 hydrogen atoms, 1, 2 oxygen, and 1, 2 oxygen. But now you realize that we have increased the number of sulfur atoms on this side because now we have 1, 2, and on this side we have only 1. So what we do is that now we add that one, sulfur. So that now we have 1, 2 on this side and 1, 2 on this side. Hydrogen are 4, hydrogen are 4, oxygen are 2, and oxygen are 2. So you see, our equation, now the number of atoms on this side is balanced to the number of atoms on this side. So now we put our coefficient. We have 1, 2 hydrogen sulfide molecules, so you put a 2 there. Then we have oxygen 1, we don't put anything. If it's a 1, it's just a 1. Common sense tells us it's just a 1, so you're not going to put anything there. So these are 2. We 1, 2, we are going to put a 2 there. And these are 2, so we put another 2 here. You see? So in that case, our equation is balanced. So this is very important when we shall be doing the mole concept. You need to know how to analyze molecules, to interpret them, and you also need to know how to balance chemical equation. It is as simple as that. It's just balancing putting what is not there where it's supposed to be. Thank you very much for watching this video. We are going to meet in the next video where we shall see more. We shall practice more on balancing of chemical equations as we put the basis for tackling the mole concept. Thank you very much.